Hello there. So today's video is about lifetimes. And lifetimes is a well-requested topic in this channel because, well, I believe because it's considered one of the highest walls for a Rust beginner programmer to climb. But hopefully this video will help you through it and maybe we can get through it together. Just leave comments, asking questions, and I'll get back to you. So yeah, let's get started. Actually, before we get started, I just wanted to say that I've decided to organize this video a bit differently. Rather than putting comments throughout the code and just going through them, I decided to make a checklist with all the topics that we'll be covering in this video. And as we go through them, we'll just check them out. Okay, so this will hopefully keep us on track and we can deliver all the content in a timely manner. Okay, now that we got this out of the way, let's actually get started. Alright, topic number 1, lifetimes in the wild. So in here I create a pretty simple example. I create a variable called r, create a secondary scope inside of main, in which we create a variable called x, which owns a value of 5, and we assigned r a reference of x. After this, we just print r. As you can probably guess, this code will not compile, but let's see why. If I cargo run it, we'll see that the error is that x does not live long enough. So what I want to do is I want to display to you the lifetime of these variables. The way that we denote lifetimes is through, well, just any letter, but followed by an apostrophe, just like this. Okay, I think that's called an apostrophe at least. Anyway, x life goes from line 4 up until line 6. So one way that we can denote that it goes from here to here is we can say, actually let's call this one B. It goes from the start of this tag up until the end of this tag. Similarly, we have R, which goes from line number 2 up until line number 8. Now something called the borrow checker is going to go through this code and is going to check if all the borrows are happening correctly in terms of lifetimes. Here we see that R is dependent on a lifetime that's smaller than its own. So the borrow checker, which is conversating with the compiler, will realize this and will throw us an error, which says that X does not live long enough. So that's sort of the intro that I wanted to put out for lifetimes in the wild. Okay, so now let's see a problem arise. In here, I created two variables, string 1 and string 2. They're both a string. This one goes from 1 to 9, this one goes from 1 to 3. And in here, I'm calling a function called longest to determine which one of the two strings is the largest. And for this function, I'm passing in references of both strings. Okay, so I'll code this function real quick. You can pause the video and try to do it yourself too, and I'll be right back. Okay, so in here, again, receive two references as parameters. I return a reference as well, so I'll be returning one of these two references. Here I just check the length of either string, which one is largest, I return it. Okay, and now Visual Studio Code is sort of spoiling it already, but for completion, I want to cargo run it, cargo run, and let's see what error we get. Right, so in here it says expected lifetime parameter. So that's our problem. Let's see the syntax for lifetime parameters, and then let's solve it. Okay, so the syntax for lifetime is pretty simple. So say here we have a reference to an i32. If we want to specify its lifetime, I just say reference. Say it has a lifetime parameter a i32. And here say I have a mutable reference to an i32, and I want to specify its lifetime parameter. I just say reference a mut i32, and that's it. Okay, now that we know the syntax, I brought back our longest function, so let's actually fix it. One piece of syntax that I didn't denote in just this previous section is that just like with generics, just like we did with generics, for lifetimes we also have to specify that we'll be using them inside of angle brackets. Then now comes a piece of syntax that you've seen. Say that x has a lifetime of a, y has a lifetime of a, and our output also has a lifetime of a. You'll see that now all the squiggly lines are gone. So if we cargo run it, you'll see that we actually get the output. Okay, so that is the solution to our problem. A couple of things I want to point out is, one, usually we only talk about lifetimes with references. Okay, so all the previous code that we wrote in previous videos of the series, they're not invalidated. Okay, the code still compile and run just fine. We just really haven't used references much in function signatures or methods. Okay, so that's point number one. Now, point number two is that by adding this here, you're not changing the lifetime of anything. Okay, rather, you're just conversating with the compiler. And in this conversation, you're telling the compiler that you want to assign x and y to have a lifetime of a, so that its output also has a lifetime of a. Okay, so I guess you can say that you're adding the compiler a constraint. Okay, you're telling the compiler that they will both have the same lifetime. So even if they don't have the same lifetime, what the compiler will do is that it will select the smallest lifetime. Now, this might seem like a lot, but I guess a real example would be, say that x has a lifetime of 10 lines and y has a lifetime of 5 lines. If you pass both x and y into this function, the compiler will set the overall lifetime to be 5. So a will be just 5 lines. Okay. Before we leave this section, let's see this in practice. In here, as it's set up, the lifetime of a will be from here up until here. But say that instead of calling the longest function here, let's create a variable called long. Let's create a secondary scope in which we'll put string 2 inside, and then inside of the secondary scope we'll give long a value. And then after this, in here we'll just call long. Now again, we set the same lifetime for both of them, and I told you that in the conversation that we had with the compiler, we told the compiler that we wanted to assign the same lifetime, i.e. the smallest lifetime. So what's a going to be in this case? In this case, a will be from here up until here. So this is gone. And again, Visual Studio is spoiling it, but we're going to have an error. String 2 does not live long enough. Okay, so again, I guess lifetimes in the wild. Okay, so before we move forward, some bookkeeping. I forgot to mark that we finished syntax, solution, and now we're talking about lifetime elision rules. So I told you before that we didn't write much code that had functions that receive references and output references. And that's true, but I didn't tell you that I didn't write any code that had that. So I went through the previous videos and I found this piece of code right here. So you see we have a function called first word. It receives a reference to a string and outputs this reference str. Okay. Now, trust me, in the video this code compiled. And how is that the case if we didn't specify the lifetime, right? To display that, or to explain that, we need to talk about lifetime elision rules. So that we don't have to look at this pixelated code, I brought it onto Visual Studio. So the first lifetime elision rule is that when we have a function that has references, every parameter that is a reference will receive its own lifetime parameter. So if we're doing that, let's play the role of the compiler. Here we'll see s. Okay, this is a reference. We'll assign it a. Perfect. Now the second rule tells us that if we only have one input lifetime. Now, an input lifetime means a parameter that is a reference that has a lifetime. The output will have the same lifetime. So in this case, this, or output lifetime, same idea, will have a lifetime of A. And this works. Now here we have a squiggly line, use of undeclared lifetime O. It's because we didn't specify it, but there. And that works just fine. So in this case, the lifetime parameters were implicit, and the compiler did it for us, because this is a pattern, and that's a pretty common thing that we do in programming. We call it a programming pattern. Okay. So yeah, whenever we have things that are done quite often, eventually it will be added onto the language's design. So some of the stuff that I might be talking about now, people might figure out that this is a common programming pattern, and they might add it onto the compiler, so you won't have to write as many lifetimes. So that's rule 1, rule 2, and I'll skip on the last and third rule for now, and I'll talk about it when we talk about lifetimes in structs. But before we move on to that, I wanted to bring back our longest example and apply the rules once again, just to make sure that we got them. So in here, let me remove what we had previously. We just have the blank, actually yes, the blank function signature. So rule number 1, every parameter that has a reference will receive its own lifetime. So X will get a lifetime of A, Y will get a lifetime of B. They get it their own. And in here we'll have to declare A, and we have to declare B. Now the second rule says that if we only have one input lifetime, then the output lifetime will be the same as the input lifetime. But in this case we don't, right? We have A and B. So the second rule doesn't apply. The compiler doesn't know how to figure it out. So that's why we have to explicitly define the lifetimes. Okay. So yeah, once again, rule 1, 2. We'll get back to rule 3 after this next section. Okay, now let's talk about lifetimes in structs. It's pretty straightforward. Say we want to create a struct called game, and it should have a parameter level, which is a reference to an i32. And here, as you probably expected, we have an error saying missing lifetime specifier. To fix it, here within angle brackets, we'll say A, and in here, the syntax A right now, we say A, and the error is gone. Okay, now let's create an implementation for game. As you probably know from generics, here you have to say angle brackets A, and here you have to say angle brackets A. Here I'll create a function, and I'll do something a bit tricky, but you'll understand the point later. I'll say function level, in which I'll pass a reference to self, and I'll pass parameter x, which is a reference to an i32. Now here, we'll just return a reference to an i32. In the function body, we'll be returning self.level, which is itself a reference to an i32. Now, from the knowledge that you currently have, you should be expecting an error. But as Visual Studio is spoiling it, we don't have one. If we cargo run, you'll see that we get a finished compiled code. So how is this happening, right? Let's go through the current lifetime elision rules that we know. Self is a reference, so it gets its own lifetime A. B is a reference, which gets its own lifetime. X is itself a reference, so it gets its own lifetime B. And now we should say in here. Okay, so in here we have to say lifetime B. We don't say A because it's already in scope, right? Is this lifetime? Let me show you. So if we say A, you see that we get an error saying lifetime A shadows a lifetime name that's already in scope. So we don't have to say it. Now, once again, you see that we're not getting any errors, right? And that's because of the third lifetime elision rule. The third lifetime elision rule says that once we have a reference to self, the output will have the lifetime parameter of the reference to self. So what the compiler is doing here, other than this, is saying lifetime parameter A for the output. And again, you'll see if we cargo run it, the code compiles just fine. So that's what's happening behind the screen. But again, common programming pattern, so we don't have to say all this. We can keep it like so. Right, so that's lifetimes and structs. All right, so now let's see where we're at. I've told you lifetimes and structs, and also told you lifetime annotations and implementations. Now let's talk about the static lifetime. To describe the static lifetime, I brought back our longest example. Well, the longest example in which we had a problem that was created to creating a secondary scope inside of main. So if you'll recall here, if we cargo run, we get a problem that string2 borrow does not live long enough, okay, because we're trying to print long and we're using it here. Now I'll do some magic. I'm going to remove toString, and I'm going to remove toString, and just like that, we get a value. So, okay, I say magic, but it isn't really. What I'm doing is making use of the fact that string literals have a static lifetime. What that means is that implicitly they have an annotation of static. Oops. Here I meant to say reference static str. Okay, and what the static means is that this reference will last throughout the entire program. And the same thing applies here. Okay, so this is implicitly defined, and it means that this reference has a lifetime for the entire program because it's stored in the program binary, if you'll recall from when I described strings. So yeah, that's the static lifetime. All right, so with that, we finished static lifetime and we finished this section. So now all we're left with is to put it all together. So let's do so. For this example, I'm going to create a struct called coordinate. Coordinate will have two parameters, x, which will be a reference to 932, and y, which will be a reference to 932. As we know, this is incorrect syntax. We'll get an error saying that we're missing a lifetime specifier. So we'll say within angle brackets a, and we'll give this a to both x and y. Okay, so we're saying that x and y, we're giving them the same lifetime, which means that coordinate will get whichever is smallest, and so coordinate cannot outlive the smallest of the two lifetimes. Okay, perfect. Now that we have this struct done, I want to create a function which returns either x or a constant. So I'm calling it x or const. In here, we're going to pass in x, which will be a reference to 932, y, which will be a reference to 932, and we'll output an i32. Let's create this const. Just in here, we'll say const, say Dan, which will be an i32, and will be 241. Perfect. Now, okay, here, of course, we'll have an error saying that, okay, this error isn't even the one we're expecting. So let's write the function body, and then we'll see the error. So say just for simplicity, we'll say if x is larger than y, we return x, else we return a reference of Dan. Okay, so now we're going to get the error that we expected, missing lifetime specifier. And in here, of course, we're getting this error because what the compiler is doing is it's assigning here lifetime specifier of A, lifetime specifier of B. Going through the first rule, it can't define sorry, going to the first rule, this is what it did. Going to the second rule, it cannot specify the output lifetime because we have two parameters, and we don't have self, so it also can't use the third rule. Okay, so what we have to do is we have to give it explicit lifetimes. So in here we define that y has the same lifetime of x. So I'll change this to be a. In here I'll say that we're using lifetime a, and the output will have a lifetime of a. Perfect. So this code should compile, and it does. Now instead of main, I'll create a variable called x, which I'll call 5. I'll create a variable called value of x, which will own a value of 5. In here, I'll create a secondary scope in which I'll create a variable y. I'll give it a value of 10, and here we're going to give a value of r, which is going to be the output of our function. Last bit in x, last bit in y, rather last bit in the references of x and y. And okay, so just want to clarify, what we're doing might seem arbitrary, but it's a drive a point. And in here we'll print line r. As you'll probably expect, in here we're going to get an error. It's saying that y does not live long enough. And this is the case because we assigned both of these parameters the same lifetime parameter, meaning that it'll receive two lifetime parameters. It'll receive, say, this that goes from line 17, so say lifetime parameter 1, to line 24, lifetime parameter 1. This is where it ends, and lifetime parameter 2 will start here and will end here. So considering that we gave it the same lifetime, the compiler will choose lifetime parameter 2, which is causing the error. So a fix is to actually give it two lifetime parameters. So instead of a, we'll give it a b, here we'll give it a b, here we'll give it a b, and here we'll give it a b. Now in here we'll keep a because we're ever only returning x, else we're returning a reference of Dan. And sure enough, you'll see that our error is gone. I mean, it's not the most exciting of conclusions, but we see that we get our constant. And this is just sort of to put it all together. We saw our lifetime elision rules here, we saw the struct syntax, we saw the function syntax, and we saw why we might need two lifetime parameters rather than one, and displayed the conversation with the compiler that we're having. Okay, so we're saying, hey, when we had only one lifetime parameter, okay, so choose the smallest, and the smallest was this, and in this case, that wouldn't work. So yeah, I can't stress enough that it's really important that you go and you try these things out on your own so that it really gets in your head. Okay? Thank you so much for watching, and I'll see you next time. Bye-bye.